Okay, so we had already done question two together. They already did question one for you. I did that with you on Wednesday and then reminded you that after the quiz on Thursday, you were going to be taking or finishing up this pages 17 and 18. It really went straight off your reference table. Where did I put my answer sheet so I don't have to look every answer? Oh my gosh, I'm a hot. I really am a mess. Where's there? There it is. Okay. We got, how about this? Did anybody have any issues with it? Any, because I'm guessing if you did it, you understood it pretty much. Okay. So these were all straight off your reference table. We've got the grain size for glassy texture. That should be no crystals, or you could put non-crystalline. Because they have no crystals, that means they cool very fast. Now, lots of people use different descriptors there. I would just emphasize that glassy is faster than fine. Like they cool so fast that nothing can form. Whereas the fine, they cool a little bit slower, and that's why they have teeny tiny crystals. So I think the regents will ask you about that? I do not. The closest thing is that they would say compare the cooling rate of glassy versus fine. And just remember that glassy cools faster than fine. They cool on the surface. The three extrusive, fine textured that are vesicular rhyolite, vesicular andesite, and vesicular basalt. For this one, the four that are non-vesicular fine, rhyolite, andesite, basalt, and diabase. Diabase is that weird one. Diabase can sometimes be coarse and sometimes be fine. So I did include it in the fine list. If they have fine texture, they have crystals that are less than 1 millimeter. Again, they cool fast on the surface. Another word is volcanic, and they have gas pockets and or which are basically just holes. Was there anything on that page that you wanted me to go through again off the reference table? You sure? Okay, doke. Like I said, if you did it, I'm guessing it probably went. Yeah, what up? Yep. Which makes perfect sense. And so you're fine for this, but why I asked you is because sometimes they will say, instead of saying extrusive igneous rocks, they might say volcanic igneous rocks. So just be comfortable seeing that here they say extrusive and volcanic mean the same thing, but your answer is fine without knowing exactly where I was going with it. But just again, same with the intrusive, make sure they will sometimes say, name the plutonic igneous rock. And that just means intrusive. So just be familiar with them. You don't have to memorize them because they're there. And that's another thing. When you're getting a question about rocks, don't do anything off the top of your head for rocks. Just if you see the questions about igneous rocks, just scan the rock chart. Those hints will come up and kind of be obvious helping out tools for you. Then on the next page, we've got the intrusive coarse textured. So again, granite, diorite, gabbro, peridotite, dunite, and again, I listed that diabase again. Pegmatite is the only very coarse textured on the reference table. Plutonic, 1 to 10, 10 or more. They are all non-vesicular because they cool slow inside the earth. This page, which I'm guessing that since I didn't have any questions from you guys on page 19, hopefully this made sense. All you had to do was decide, is the rock, so pegmatite was the first side. Pegmatite is to the left of the word color, to the left of the word density, and to the left of the word felsic. So pegmatite is light, low, and felsic was all I was looking for there. Granite, also light, low, and felsic. Gabbro, dark, high, and mafic. Pumice is light, low, and felsic. Basaltic glass is dark, high, and mafic. Scoria or vesicular basalt are dark, high, and mafic. Rhyolite are light, low, and felsic. Basalt, dark, high, and mafic. And vesicular rhyolite, light, low, and felsic. You might, just to cover teachable moment here, See how none of these three were the answers to anything? So these three that are just in line with the word color, density, and composition, they will never ask you, are they dark, low or high density, or their composition. These ones, they're kind of like in between. So the good news is they'll never ask you about them. They only care about these ones or these ones when it comes to light, density, color, and composition. And then just to wrap it up, mafic rocks are dark in color, have a high density, contain iron, and you could have put iron or Fe. Either one works for me. Ooh, actually, question: do you know where to find what Fe means? There's two different. It is the periodic table, but we don't have one of those in our reference table, so no one's asking you to memorize that. There is a key down here on the mineral chart. So any mineral or any element that's in any of these minerals is defined. So Fe is listed right there. But they do also give you this list on the front page of our reference table. So a few common elements are listed here. So again, Fe is iron. So again, mafic rocks are rich in iron and magnesium. And then felsic rocks, they are light color, low density, silicon and aluminum. And I didn't care if you put the abbreviation or spelled it out. Everybody good with that? Was there anything on page 19 that tricked you up? Okay, so the 5 mafic rocks, I listed all of them. They only wanted 5. So basaltic glass, scoria, vesicular basalt, diabase, periodite, gabbro, and dunite. The felsic rocks on the other side, obsidian, pumice, rhyolite, vesicular rhyolite, granite, and pegmatite. Again, you only needed 5 of those. The minerals, I got to make sure you know how to do the minerals for the next part down. So let me just make sure we're clear about this because this is what we're doing today. So obsidian, pumice, vesicular rhyolite, granite, and pegmatite. They asked what minerals are in those. So the minerals are listed down here. Each rock has its own box. So anything that is underneath any part of that box, not even just like, even if it's just a little tiny bit, as long as it's underneath the box somewhere, it's in there. So for those first ones, potassium feldspar, you can abbreviate that, by the way. Quartz, plagioclase feldspar. Now, this one's in there, even though the name is hidden underneath your Post-it note, as long as the symbol is underneath it, it's in there. So then there's this black one, which is biotite, and the darker stripes, which is amphibole. So again, potassium feldspar, quartz, plagioclase, biotite, and amphibole. For obsidian, andesite, and diorite, that's quartz, plagioclase, feldspar, biotite, amphibole, and pyroxene. Basaltic glass, vesicular basalt, scoria, all of those. We got plagioclase, biotite, amphibole, pyroxene, and olivine. Periodite is just pyroxene and olivine, and dunite is just olivine. Coarse crystals, I gave all of them. You did not need to include all 6, but it's granite, diorite, gabbro, periodite, dunite, and diabase. Light in color, pumice, rhyolite, granite, pegmatite, vesicular rhyolite. High in aluminum was a way to trick you. It says right here that felsic minerals are rich in Si and Al. So when they are asking about high in aluminum, they might as well say which ones are felsic. So felsic ones that are high in aluminum are obsidian, pumice, rhyolite, vesicular rhyolite, granite, and pegmatite. And then high density, any of these ones: basaltic glass, scoria basalt, vesicular basalt, diabase, gabbro, dunite, and periodite. Got it? Okay, you guys, we have literally one thing to do before you can start your homework. And so we're going to be right on page 20. The top part, oops, not that packet, this packet. You already know how to do half of what I'm asking you to do today. So we're starting right here, the top half. It says percent of minerals found in rocks. So I want you to determine the percent of various minerals that would be in each of the following rocks. So we're going to start with granite. Now, we basically already did half of this just a moment ago. So first of all, can you list the minerals that are in granite. How do we figure out the minerals that are in granite? The mineral composition. So that's the part, the minerals that are listed underneath it. You got it. So just here's how I like to use Post-it notes to do this part. So again, I'll just show you in case you didn't know how to do it. So here is granite's box. Anything that's listed underneath granite is in granite. So I like to kind of section off granite, bring these down. They've got the dotted lines to help you. So the minerals in granite, like we just said, like what was that, 3 minutes ago, if that? Why can I not keep track of it? So the minerals that are in granite are these guys. So you can fill those minerals in. We don't know how to do the percentages yet. So we're going to just list the minerals in granite. And they are potassium feldspar is first. Now, people want to abbreviate the word potassium and or the word feldspar, and you can. Just don't put P feldspar because there's two different P feldspars. So I abbreviate potassium feldspar as just pot feldspar. And then we got the polka dots, so that's quartz. And then the lines, which is plagioclase. Again, I abbreviated that one plag. We got the black, which is biotite. And the darker stripes, which is amphibole. Everybody knows how to do that part, right? Awesome. Now the percentage. This is a little tricky, but you may have noticed that there are percentages listed over here. And there's a couple ways to do this. I'm going to show you the easiest way with zero math involved. You might be a great math student and figure out there's a different way to do it with math, but I'm not going to teach you that way. I'm going to teach you the easiest way possible. So granite, this is granite. This is a piece of granite right here. It should look like some countertops. This one, I think it's a little too busy. I wouldn't want this on my counter, but to each their own. Each one of these little different colors, not sure if you guys can see, but there's some pink, there's some white, there's some black, and there's some like more clear colors. That's because it's made up of these minerals, which can be pink to white, white, white to gray, black, or black. So these minerals are what gives granite different colors. Have you guys ever seen other kinds of granite that look different than this one? You've seen a red one? Anybody seen other color granites? Like countertops, like granite countertops. There's just gray ones. There's ones that are more black than others. There's ones that have no black and are more pinks and whites and grays. And that's because even though granite has these minerals in it, sometimes granite will have less of one or more of the other. So what we can do, and it kind of depends on where we measure. Like if we were looking over here, there would just be like a little tiny sliver of this pink one and a lot more of this white to gray one. So what we need to do is find the average piece of granite. So see how the word granite is centered in its box? So what I need you to do is take your Post-it notes, and you might want to, I like to line up the Post-it notes so they're a little taller. So I just stick them together. Or have a larger, does anybody need Post-it notes delivered? Okay. Or just use a taller piece of scrap paper. I have you just because I've already passed out the Post-it notes, use the Post-it notes. If you line up your Post-it notes with the center of the word granite, which because granite is a 1, 2, 3, 4, 5, 6, 7 letter word, it's in between that fourth letter, which is N. So the N is the center of the word granite. Try and keep your Post-it notes nice and straight. So you should have your Post-it notes going down the center of the box. What we're going to do is mark off the bottom of the mineral box and the top of the mineral box. So we're just measuring how tall it is. Now we're going to make a mark to mark off the top and bottom of each section. So what I mean by that is I already have the top marked off for potassium feldspar. Now take your pen and mark off the bottom of it. So I just now have the top and bottom of the plagioclase feldspar marked off. Do the same thing with the quartz, the plagioclase, the biotite, and the amphibole. So you basically have a bunch of little marks on your scrap paper. I would also add a quick label. So what I'm going to label that, and I'm labeling the section, like the area instead of the lines. So that's potassium. I abbreviated it POTS. This is quartz. I'm just going to abbreviate it with a Q. This is the plagio. This one's the biotite and the amphibole. So it basically just measured off how big each section was. Now here's where you can either do math or do it the easy way. If you bring this over and line it up with the scale, can you tell me how tall your amphibole section is? So it goes from the 0 up to the second mark, which hopefully you saw that those go up by 5s. So the amphibole is 10. Now, of course, you could do math to tell me how tall the biotite section is. I don't like math. Here's the trick. Move your Post-it note now down so the bottom of the B is at the 0. No math involved. So how tall is the B section now? Should be 10 again. Now, I'm sure some of you saw that it started at 10, ended at 20. You could have subtracted them, but who wants to do that? So this one again is 10. Now do the same thing for the plagioclase box. Move the bottom of the plagioclase down to the 0. How tall is your plagioclase now? Goes up to 20. Move the bottom of your quartz section down to 0. How tall is that one? Minus 40. And move the potassium box down. How tall is your potassium? Mine goes up to 20 again. Now, I labeled them on my Post-it note. Now I have to transfer that over to my list over here. So just make sure you're transferring it in the right section. My potassium feldspar should have been 20. Quartz is 40. Plagioclase is 20. And then 10. And then 10. And by the way, what should these add up to? They should add up. 20 plus 40 is 60. Plus 20 more is 80, 90, 100. Easy enough? Do the next two. Do diorite and basalt going down the middle. I'm going to come around and help anybody who needs help. All right, so just in case you want to check your work, I have for diorite, and your answers can be off, I'd say by 5 from mine. I had, and the order doesn't matter, I had 30% amphibole. I did see some 35, so that's fine. I had 15% biotite. And I had 55% plagioclase. Now, the next one does present a few issues. So if we go to basalt, basalt is here. Now, if I asked you what minerals were in basalt or what minerals could be in basalt, you're going to be noticing that basalt has quite a few choices. It could have the stripes, which is plagioclase. It has a bunch of pyroxene. It has a bunch of amphibole, and it has some olivine. But you might also notice it's got this little tiny bit of basalt in it. But when you go to do the percentage of the average piece of basalt, remember we're going down the middle of the box for basalt. So when you do that and you mark off the top and bottom of each one, you'll see that that biotite doesn't even make it into the list. Yes, a teeny bit of the olivine does and a little bit of the amphibole, but down the dead smack center, there is no basalt. I keep saying basalt. No biotite in the middle piece of basalt. So when you take this over, again, depending on what order you went in, to me, my plagioclase looks like it's a little bit more than 30. My pyroxene is 60. Olivine is about 5, and amphibole would be a little bit less than 5. Do you have to get it exactly dead on? No, you don't. Again, I went with 5 of amphibole for mine, 5 of olivine. So apparently when I did this, I had 55 for pyroxene. And what's the one I'm missing? I had plagioclase. Yeah. To me, that one must have been up around 40. Was that true? I don't remember now. Yes, 35. There we go. Okay. Again, hopefully you're able to get those right answers. You do have homework. It's pages 21 and 22. It is 16 multiple choice questions about igneous rocks. You will have a quiz coming up on igneous rocks. I would make sure you're able to actually answer these questions about igneous rocks and not just BS your way through them.